All right, so today I'm going to be looking at a simple wind tunnel and a 2D circle. I'll put in the middle. I'll pull up the geometry I'll be using real quick. So this is what I'll be using. Um, I've already done primarily the geometry in the mesh because I think it's easier that people watching don't have to wait for meshing time and whatnot. Um, so I'll go to my workbench and then I'll pull up my geometry. All right, so I'm assuming most people watching have a general idea of how to do this, but just in case they don't, it's gonna start at a diagonal. You're gonna want to press this Z. Well, it's not really gonna look like that necessarily. Right, you would want to press like the Z, taking it set to the X, Y. Y should be vertical. X should be to the right. Y should be facing up, sorry. Um, And then you're going to want to start to draw your shape. So if you go to, well, first check your units. I didn't need to change anything because I was on meters for this project, but if you want to do something else, just something to keep in mind. All right. So you can use, lines or rectangles to start. I to start made a rectangle from the origin for my test section. And then I just use lines and basic geometry to make the rest of it. To get your dimensions, because you're gonna get your exact dimensions, you would press dimensions, then you can drag from the circle to say give your diameter or from any of these edges. It will give you the exact dimension, and then if you want to actually adjust this, you can just click and you can edit your geometry. So basically what I did was using dimensions, or it'll adjust your length or your diameter, whatever it is that defines that element, that shape. Um, so I basically have my wind tunnel here. Here's the inlet. Here's my outlet, right? Once you have your general shape, you want to make sure that there's no extra lines, you could say, in here, or else it'll mess things up. So then you're going to want to go to Concept, Surfaces from Sketches, right? You're going to want to click on any of these edges. You can click the circle edge as well, right? And then it's going to light up all blue, and you're going to want to click apply. It'll light up all blue, and then you can click generate, and you should now have this sort of gray object. So first, your sketch needs to be somewhat enclosed, or you're going to have issues, right? Like you don't want to leave your inlet open to everything. Your inlet's going to be an edge as well, right? Things like that. Um, So as you can see, there's no extra lines in here. Everything where there's gray, there's going to be airflow. Where there's no gray, there's going to be no, or air fluid flow, I guess, depending on what you're using. Right? So I want to test the flow over the circle. So there's going to be no flow, and here's going to be flowing over the circle, right? Because obviously it's not gray. All right. So that's good. So once I have that, I'm going to exit out. I guess if you were doing this for the first time ever, maybe you would want to right-click geometry to even get to that. You would want to right-click geometry and you would want to click New Design Model or Geometry. Mine says Edit, but you want to click New Design Modeler. You want a green check mark. If there's not a green check mark, you could just go to Update, press Update, and you'll be good. So then you would double-click Mesh next. This is usually going to take a minute. I already have mine pulled up, thankfully. So here we go. And yours is initially not gonna. It's gonna sort of look more like this, and mine's gonna look different in a moment. I'll show you, but we're gonna once again set it to this XY to the same coordinate plane. All you're gonna see is mesh. You're not gonna see these name selections. So the first thing you'd want to do is right-click mesh, go to Insert, and you're gonna want to insert method. All right, you're gonna want to click a face and apply, and then you're going to want to, before you click apply, you want to switch. It's gonna start as quadrilateral. You want to switch it to triangles, right? And then you would do generate, right? Now you'd have a sort of still gray shape with these much larger triangles throughout it. Um, but it's not going to be very accurate, and so we want to change that, right? So next thing I'm gonna do is I'm going to adjust my edge sizing. I adjusted my edge sizing in portion, right? This blue arrow is depicting the edge, but you don't need to do it that way. So what you would do is you'd go to, say you want to just do your circle, then you could do the other edges separate, for instance, right? You right click mesh, go to insert, and then sizing, right? And then using the edge tool, you'd select whatever edge. Say you wanted to treat a group of edges all together, right? You would just do control. And then as you can see now, I can select multiple edges at once, as many as I like. Or you can don't do that and it'll select them individually, as you can see, right? So I have mine grouped circle, and then I have the test section, and then I have the inlet outlet and these diagonal sections, right? So for this, I could have actually done it all together. Um, but I wanted to be a bit more precise on the circle because my project wants me to zoom into that. So for this, for my circle edge sizing, 0.0005 meters. And then for my actual edges, I believe I did 0.001. All right, right. Okay. But if I go to mesh, what you're gonna see is, so this is my general mesh size, which I changed to 0.01, and that's gonna be for the whole entire face, right? But this isn't accurate enough for what I really, really want to be looking at, which is the circle. But now if I were to do something as small as a circle throughout the whole wind tunnel, it wouldn't work. It would take forever to load, and for ANSYS student, you may even run out of cubes to, or I guess just objects. You may run out. There's a peak, I believe it's, I want to say 500,000 or something like that. All right. So we want to sort of be able to focus on what we want to. So I did smaller edge sizes so I can capture a boundary layer, right? But for the circle, I want to have it go even further, right? It would blend far too quickly. I don't want to only be able to see accurate maybe out to here. I want to go out a bit further, right? So from there, I right-clicked mesh, insert inflation. So you're going to want to select a face for the geometry, and then you're going to want to select the circle edge in my instance for the edge boundary, right? Now, say you wanted to do an inflation from this edge, you could do that as well. For me, I just did the circle, right? Um, and the same aspects sort of apply, right? Actually, before I move to this, I set capture curvature to no, and I set behavior to hard. It should help with boundary layers a bit. Also save a little computation time, which is pretty important. Now let's go to inflation. So there's a few different types you can do. I have first layer thickness. You can do smooth transition, but first layer thickness I tend to find seems faster when I do it that way, and the result is fine in my opinion, right? But so this is, as you can see, our inflation looks much different than than these triangles that we have, right? Um, so growth rate is basically how quickly it's going to expand, right? You can set your first layer height, pretty self-explanatory. It's just that first layer on the boundary. Then max layer. So say I only did, like you can see I have 130. Say I only did like 50 layers, maybe this the circular section would only extend to here, right? So I think you get the point. It's simple enough. Most of this time spent on this is just sort of going to be getting a quality mesh and just the computation time to make the mesh. It'll take a few minutes sometimes, depending on how accurate it is. So that's okay. So now you're going to want to make sure to name your selection. So you're just going to want to click an edge, click N, right? And then you name it whatever you want. Make sure, I mean, it could be whatever you like, but it helps to be relevant to the object, right? And now if I were to click on each one of these, it's going to point it out with the red arrow, right? So I name this inlet. I name this outlet. I name this circle. Simple enough. And now for these edges, you could do this a variety of ways. Say you wanted to name them all together. You could do control, just like earlier with control, select all these edges at once. Now, if I were to do N, I'd name all these at once, right? So maybe you could do like top one, top two, top three, bottom one, bottom two, bottom three. I chose symmetry. Um, I'll explain why in a bit, why you may want to or why you may not want to. I didn't really need to technically, but just for simplicity, because I'm going to be treating these edges as all the same, I'm able to, but I'm actually going to have to change something later in the setup portion because I did that. All right, so now that everything's selected, right, I can minimize this. You're going to want to update this. There's probably going to be a lightning bolt, so once again, you'd right click and then update, so you get a green check mark. So now let's go to the setup, and I'll actually I'll run the sim just to show the residuals. I think this should be a bit quicker, so if you're willing to wait 30 seconds to a minute, I think most people are. That's fine. So I've already done it just to make sure everything's correct, but when you first open this, you're not going to see this. You're just going to see zoomed out a green model, right? That's all you're going to see. It's just going to be all green basically, right? So you're going to want to go to models. We're going to ignore this, but we're going to double click here, right? And now for here, you can set your sort of flow model. So you could do inviscid flow, laminar flow, right? And then here is sort of your turbulent flow types. I've used this in the past it's good for external flow, but it's a bit simpler, which is nice. Um, K omega SST is sort of good for wind tunnels. It's good for boundary layers. It's good for separation. So that's what I'm going to use for this, right? Because I want to see the boundary layer on the circle and on the wind tunnel. So that's okay. I'm going to go with that. It's all good, right? Materials, say it's going to be set to air, but you could do solids, right? You could do fluids. If you wanted to edit that, you could just double click or right click. I'm not going to because I'm just using air for this project, so that's fine. Nothing to change. Double click boundary conditions, right? So now we can edit things here. So inlet should be velocity inlet, and excuse me, I have my velocity set to, I believe, like 5.85, so that's good. You can also mess with your turbulence if you want to. Here, if you're doing laminar and viscid flow, that won't be available, of course. All right, and then your outlet should be a pressure outlet with 0 pascal gauge pressure. Um, Sometimes, depending on your shape, you will need to uh, prevent reverse back or reverse flow. I'm not going to need to. I had no issues with that. That's fine. Right, and now, so here's the thing where symmetry you may want to or may not want to use. By naming it symmetry, it actually already knows, and it won't start as wall. It's going to start as symmetry, right? Symmetry is going to treat this when I show if I were to show the velocity, it's going to treat it as it's going to ignore the no slip. So there's going to be, I guess you could say, a slip condition, right? I'm using viscous flow, so it wouldn't make sense for me to do that, right? Unless for whatever reason I wanted to see the no slip on the circle, but I was okay with slip on the edges. I just named symmetry just for simplicity to combine it, but I'm actually in this case going to move it just back to wall, right? Wherever wall went, should be at the bottom, sorry. And I'm going to make sure that I'm going to show how to edit the wall. I need stationary. You could do a moving wall if you wanted. No slip. You could do a specified shear if you want, and you could adjust your shear, but I'm going to do no slip. So I'm going to close that. You could also adjust roughness if you wanted to. I'm not going to. Um, so everything's where we want it to be. Then you're going to want to go to reference values. All right. This is going to be empty, but I'm going to do compute from inlet. Right? And it's going to show my velocity now. It's all correct. All right. Then you could do, in this case, we won't change methods, but you could change the methods if you want. Certain, some of these will calculate faster, but they'll have some issues with the results. So for instance, Presto, which should be right here, I don't really have much issue with it for inviscid flow, but if I try for, say, laminar or turbulent, there's no convergence like ever. The residuals are terrible. And the flow visualization is awful as well. So we're not going to do that. All right. Monitors, right? You can change your residual that it's going to finish at if you want to. I'm not going to, but I'll just double click just to show it. Why not? Right? I could lower this if I wanted to, right? Um, Well, let's just lower it for the sake of it. Why not? Let's just do 0.01 for all of it. So there's actually finishing pretty quick on 0.001. So let's do 0.01. How about that? Right? And then so say it meets this criteria before the 1,000 iterations I have it set to, it'll finish, right? Okay. Right. So we're going to close that. Initialization, you're going to want to double click. More settings. This is going to be start as 10, but I have it set to 25. You would press initialize. Okay. And then I'll run in this command down here. It'll go to 25. Just give it a moment. And then basically double click run calculation. This is going to be set to 0. I have it set to 1,000. And now we're going to calculate. So this will take, a bit of time, but not too long from what I was seeing earlier. And I'm going to pull up our residuals. I was looking at drag coefficient earlier, but we don't need that. All right, so here are our residual lines, right? Ideally, you want them to start to descend if they're like super erratic, up and down, growing. That's not ideal generally. All right. So I'm just going to give it a moment to do its thing. Right, so basically now you can set the line residuals to uh, a different value for each line, but they're all 0.0001, right? It has set. But say I left it at point um 0.001, it would be just about finished, right? Because as you can see, our top line would be below. But since we lowered it, it's going to take a bit more time, so just give it a moment. Would be interesting actually if it doesn't converge anymore. Right? 0.001 is was like the sweet spot. So this is taking a bit, so I'll pause this and then I'll come back when it's done. All right, so it's all done. It really didn't change a whole lot after that, so that's fine. So first thing I want to do for this is I want to look at velocity and pressure contour. So I'd go to results, right? Contours, new, right? And then you can name this whatever you want. I'll do velocity first. You go to velocity. Velocity magnitude is what we want. And then you'd select everything, right? And then you'd compute, save and display. I already have the velocity, so I'll double click. Right? Name the velocity. As you can see, it's basically identical. Compute, save and display. Give that a moment to load. So here's our velocity contours, right? So this sort of represents what we would expect, which is good, right? So we have obviously our, uh, I guess our key or our Yeah, I guess you'd call it a key on the side here. Um, and then this sort of our actual contours represent what we would expect to see for this, right? So as we know, obviously there's not necessarily an area because it's just two-dimensional, but as we squeeze the air into a tighter area, our flow rate needs to stay the same. And if it's in a tighter gap than before, therefore it has to speed up to maintain the same flow rate, right? So we can of course see an increase in the velocity around here. We can see these dark blue bands along the edges where there's our no slip condition, right? We can see some increase over the corners, which is once again, that's fine. We can expect that. So if we zoom in a bit further, right? As you can see, you're you can see where this inflation comes into play, where if we're looking at this, this would not be accurate or this would not be satisfactory for this to really analyze the flow around the circle. So this inflation is excuse me, very important because we can see with more accuracy and detail what's going on. So we can see our stagnation point where it's hitting the front, where velocity drops to initially zero, which is to be expected. We once again can see this light blue or this dark blue band where there's the no slip condition. We can of course see the velocity increase if we almost treat this, if we cut this in half and almost treat this almost like a wing, right? Of course, it's being squeezed into this tighter area in a sense. So we're going to see velocity increase. And of course, we're going to see the wake behind this. Right, so this is what we would expect. This is correct, right? And then if we could add another contour for pressure, same exact thing, right? New, I've named mine pressure. You click that, right? I want to see static pressure. Now, if you wanted, you could do, pressure coefficient, dynamic, total, you get it, all these options, but I want to do static, right? Let's compute, save and display. All right, so now if we, excuse me. Right, so now if we zoom out, we of course see our higher pressure coming in. Where it's very fast along these edges, we see our low pressure. As we know, velocity corresponds to an increase or a decrease in pressure, sorry. Right, so if we zoom in even further, we can see our stagnation point where there's the high pressure zone forming in front. See the low pressure zone where we have our increased velocity, and then we can see some wake where the pressure is also somewhat lower than, say, right in the front here. Due to it's a bluff body that's having to push through this area and it's leaving this lower pressure wake behind it. So everything there is correct. All right. And then I had to find the coefficient of pressure plot. So, excuse me. To do that, you go to XY plot, double click that. All right. I just have XY plot one. Let's just change it to CP because why not? All right. So I have pressure. Um, static pressure, but we want to change this to pressure coefficient. And I'm plotting this along the length of the circle. So you could do curve length, but you're going to run into issues where it kind of just looks like a bunch of squiggly lines and parabolas, which just doesn't really tell you a whole lot. So we're going to do direction vector, save and plot. All right, so now here we go. This is good. All right, we can of course see this would be the front of the circle. This is going to be the back. We can see this higher pressure zone in front at that stagnation point, which is what we would expect. We have this lower pressure, which is where we would see, maybe a third of the way, approaching halfway back of the circle, right? If we're looking at it just the diameter of it, right? Where our velocity is the highest. It starts to rise again as our velocity starts to slow a little bit on the back. But because it's a body pushing through this zone, we're gonna have a wake of low pressure behind. So it's never quite going to equalize to the initial nor the stagnation point, which is what we would expect, right? Now, it's worth noting that this is not, I should clarify, this part is not necessarily the wake. This is still on the circle, right? If that makes sense, this is still along the length of that circle. However, right, it's, as you can see, it's still not going to come back to the initial value. the wake, if this makes sense, would technically start here and back, but we're not looking for this instance, we're not looking for the wake pressure. We're looking for, or pressure along the wake canal change. We just want the length of the circle. So there we go. Everything's correct. And then the last thing I want to do is the drag, right? So you see a lot of things that say gonna want to go to reports and forces. Don't do that. That's wrong. Go to report definitions. You would double click that, right? I'll just try to do it. You double click report definitions. You could do new if you wanted to, right? Surface, volume, force, flux, mesh. You would do force report and then drag. So I'll close this out because I already have one. All right. So I just selected circle because I wanted drag on the circle and not for the whole wind tunnel, right? Drag coefficient. I want I think I wanted the coefficient, not the force, right? Yeah, I wanted the drag coefficient. All right. So then circle, drag coefficient, compute. Okay, yep. And then it's going to give it to you in your command window down here. So everything is good, everything's correct. All right. And hopefully for anybody watching, if you had any questions or maybe you want to follow this along exactly, or if you just wanted perhaps some help on a general topic, hopefully this was helpful.